Welcome back to another episode of Program That Part. Today we are going to program this part, and this happens to be a top half of the Ford Focus ST RS short throw shift kit. And this normally would be done in a fixture, but since it's by itself, this is the first time I prototyped and everything. I'm just going to show you how I programmed it within the first prototype. So to start off with, we have a piece of stock that is 3 by 2.5 by 1. And this, I have the coordinate system right in the middle of it. And the part is directly right in the middle of the piece of stock. So we're going to come down and face all this material off right here. And that will be the first operation. As you'll see right there, I'll come down with the Superfly and just machine all that off. 2500 RPM at 20 inches a minute, that's my normal cutting feeds and speeds for the Superfly. Usually cuts pretty good. Selected this chain here and left everything else the same. Oh, multiple depths. I'm going 40 thousandths of an inch per pass. Then I'm going to come in with a 3/8 flat end mill, the Taz. This is the aluminum shredder from Lakeshore Carbide here. 5500 RPM at 40 inches a minute. I'm going to select this top part, and then we will select for the bottom height, we will select this face right here, and then go -5 thousandths below that just to make sure we get everything below it. And for the top height, we're going to select this right here. I'm going down 1/4 of an inch each pass, and I'm leaving 10 thousandths of an inch on each side. And the optimal load is 35 thousandths of an inch. Then we're going to come in with a drilling cycle, 17/64 drill, and it'll drill out these 4 holes. So at 5,000 RPM and a plunge feed rate of not that fast. Must have messed that one up somehow. That should be somewhere around 15. Selected these 4 points here. The geometry, you can see those there. Just selected these circles and that gave me this point. And I have selected points selected rather than selected faces. And for the top height, I selected this face here. And the whole bottom is basically what they gave me. Like, it's selecting each whole bottom from the point I selected. And I'm breaking through another 2/10 of an inch below that, so I'm making sure I get way through. And this one's sort of up there a little bit longer. That's just so when I flip it over, I can make sure it's cut all the way through. And I'm going 50 thousandths of an inch pecking depth and full retract pecking depth as well with that. Then we're going to come in and adaptive out these counter bores right here. So get all those counter bores out, and this one will be a through hole, just a regular through hole for a stud basically. It looks like it's a ball stud is what it's for. So at 7,000 RPM, 75 inches a minute, I am going to counterbore these holes and then cut this through hole right here. So I selected those 4 chains, and the top height is this face here. The rest is selected contours for the bottom height, and my optimal load is 15 thousandths. And stock to leave on the sides is 10 thousandths, and that's so I can come back with a cleanup pass. And the rest is left the same. Actually, no, I'm using pre-drill position since I just drilled those out, so that means the end mill will come down, just plunge straight down. Well, there won't be any stock there, so it's plunging into nothing, and then adaptive out the rest of it. And that just eliminates all the helix that it would do if I didn't have those holes drilled. And then we'll come in and contour out those counter bores there. 7,000 RPM at 75 inches a minute. Selected the same profiles there, and it just does the same thing. All this is left the same. All that's left the same. It just pretty much cleans up those contours there. And same with this one. We're going to clean up the outside. 5,500 RPM at 35 inches a minute. I will clean up this outside piece, and I'll select this chain here, and I'll have the bottom height the same one I did before. Selected this bottom face and went 5 thousandths below it, and the top height will be this selected face right here, and the rest will be the same here. And then we are going to come in and trace with an engraver. This is my logo here. I brought this DXF in and just put it right on top of this thing. So at 7,000 RPM, 30 inches a minute, I will select this chain here, just basically select all the sketches within this sketch, and everything here is left the same. So this axial offset allows me to actually plunge into the material here, and that will go 5 thousandths into the material. and that's what we will come up with after we're done. So that is the first operation of this part. So now we're going to flip it over and hold it in the vise just like this. So we'll come in with the Superfly again in this second operation and just clear everything out. Same operation as we did before in the first setup, but this time it's just flipped over. And we do this operation alone by itself just because once we clear all this material out, then we can locate off this thing and it'll be a solid location, so we can get right in the middle here. For, I guess you would call this the third op, but it's still in the same. We don't take it out of the vise, we just keep it there. We just locate it again with the Heimer. So we're going to come in and adaptive, and this adaptive is going to be more or less a facing operation here. So with the shear hog, 4500 RPM at 50 inches a minute, we are going to select pretty much anywhere on this top face, and that will allow us to face off this part here. And the bottom height we will select as this face. All three of these little pads here are the same height, so that's what we're coming down to face everything off. And we're going to have an optimal load of 80 thousandths, and we're going to have no stock relief, but for some reason it is selected, but it should not. And everything else is left the same. Then we're going to come down with a 3/8 of an inch end mill. It's the aluminum shredder again from Lakeshore Carbide, 5000 RPM at 35 inches a minute. This is a regular 3D adaptive, so we selected this chain here from stock contours, so selecting the stock out here, and rest machining from previous operation. So just to make sure all this top stock is gone, it just wants to know that. So coming from the top height of this face, and the bottom height will be this face right here. And we're going to leave a radial stock to leave of 10 thousandths, and we're going to have an optimal load of 45 thousandths. Then we'll come back with a contour, and that will just contour out all of these. We didn't really need to do this contour because the horizontal will take care of that. Once we come down with the horizontal, it cleans up the floor of this. It will also get all of these sides here. So we really didn't need to do this contour, so I'll just show you the horizontal. With a 1/4 inch flat end mill, we're going to go 5500 RPM at 35 inches a minute, and basically we select this face here, and that just wants to know where the part is, I guess. Not really 100% sure, but we specify a top height, which is right here, and then the bottom height, which is this right here. So it'll only go between here and here. And on this top height right here, we selected this face, but we want to make sure it doesn't clean up anything on this pad right here or any of these pads, so we selected that it goes negative 10 thousandths below that. So then we just get everything on this right here, so it just cleans up this floor, and everything else is left the same. And this is what that tool path looks like, where before on these pads, if we didn't have that negative 10 thousandths selected for the top height, then it would try to remove material up here, and we don't really want that. After the simulation, that is what we end up with. And this hole right here is threaded, but I just manually threaded it for this occasion here. And you can sort of see what it looks like with the engraving. So there you have it.